It's 2015, and GPRS Senior Project Manager William Johnson is more than a mile below the Pennsylvania soil, scanning a concrete pad poured into the floor of a mine shaft. He's completely alone. The light that's strapped to his helmet is barely holding back the inky darkness around him. If Johnson's headlamp dies, he's been instructed to stay still until someone comes to retrieve him. He briefly shuts the light off just to get a sense of how dark it truly is in the bowels of this cavernous space. He can't see anything. He'll later say it's the darkest dark he's ever experienced. Thankfully, his headlamp does turn back on as soon as he's finished with his experiment. Johnson was a fresh face at GPRS, having only joined the team a few months prior to being called out to what he thought was a routine concrete scanning inspection. All he knew was that it was a mining facility, and they were interested in obtaining an accurate slab thickness for an existing concrete pad. When he met up with his site contact, he was told to load his scanning equipment into a waiting golf cart. He was given a jumpsuit and a hard hat, and the next thing he knew, he was being driven into a mine shaft. It took them about 30 minutes to reach the location of the concrete pad. At this point, they're anywhere from a mile to 2.5 miles below the surface. Johnson needed to determine the thickness of the slab so that the mining company could determine if it was strong enough to support a heavy piece of equipment they needed to move into the mine. At the time, the most sophisticated and accurate ground-penetrating radar controller of this kind of work was the SIR 3000. It was a heavy setup, but despite the challenges he faced in navigating this inhospitable environment with unwieldy equipment, Johnson successfully determined the thickness of what must be one of the more unusually located concrete slabs in the world. He doesn't remember whether it took 2 hours or 4 hours to finish this job. Being a couple miles away from sunlight tends to make it hard to keep track of time. But what's important is that despite the unique conditions and challenges at play, his work was accurate. That accuracy ensured that our client knew where they could and couldn't place their equipment so that the miners remained safe during the project. Keeping people safe. That's intelligently visualizing the built world.